All right, well, per popular request, I'm going to make a couple of videos here. And people asked for some problems to get worked out, so I am going to do number 29 from your homework. And it is taking a look at this equation where calcium carbonate is decomposing into calcium oxide and CO2. And as you can tell, this is already a balanced equation. One carbon, one calcium, 3 oxygens, 2 and 1, so there's 3 oxygens. And the question, and I guess I can edit it in, but you can read it. It says, what volume of CO2, so I'm looking for volume in liters, I'm guessing, of CO2 can be produced, so collected at 55 degrees Celsius and a pressure of 774 torr, is produced by complete thermal decomposition of 10 grams of calcium carbonate. So 10.0 grams of calcium carbonate, and the CO2 that I'm collecting is going to be at a pressure of 774 torr, which is just another name for millimeters of mercury, kind of antiquated, but it sneaks its way into our vernacular. And 55 degrees Celsius, so that's temperature, is 55 degrees Celsius. So it's sort of a typical gas stoichiometry problem. It gives you grams of a reactant, asks you for liters of a product. Now, previously, we've done lots of problems where it would give us grams of a reactant and ask us about grams of a product. So that would go something like, you'd go grams to moles of calcium carbonate. You'd go from moles of calcium carbonate, you'd get moles of CO2, and then after you had moles of CO2, you could convert that to grams of CO2. And you guys, my students, are all really adept at this. So the only difference in this process is, rather than try and get grams of CO2, once we have moles of CO2, we are going to want to find how many liters will this carbon dioxide occupy at the given pressure and temperature. So it's a pretty typical stoichiometry problem until you get to this volume part. So this 10 grams, so 10.0 grams of calcium carbonate. We're going to multiply that by 1 mole of calcium carbonate. And I sat down to do this without a calculator, but I know that carbonate is like 60 grams and calcium is 40, so that's going to be 100 grams, give or take, per mole. So that means we are looking at 1/10, so 0.10 moles of calcium carbonate. And then since the balanced equation, all the coefficients were 1, 1, 1, implied by there not being any coefficients, that means our moles of carbon dioxide is going to be 0.10 moles of CO2. Now, if I'm going to use, and I would hope we would recognize, you have P, T, and N, and need to solve for volume. So we are going to use the ideal gas law, and that is PV equals nRT. So we have P, T, and N, but we need R, and R is a numerical constant, 0.0821, and that is liter atmospheres per mole Kelvin. So that tells me that all of these other measurements need to be made in particular ways. Volume in liters, so that's going to come out in liters. Pressure needs to be in atmospheres, which we currently do not have. moles, so that is nice, and temperature needs to be in Kelvin. So we can convert the temperature to Kelvin easily enough. It's plus 273. So into our equation, we will put, what is that? 298 and then 30 more, so 228 Kelvin, 328 Kelvin. And we're going to go pressure to atmospheres. So that is, there is 1 atm for every 760 millimeters of mercury. And so 774 divided by 760 is going to get you a little over 1, right? So we'll calculate that up. And then everything can go into PV equals nRT. And when we solve for V, it will come out as liters of our carbon dioxide. So if we rearrange this, I'll divide P over to this side. And so we end up with volume equals moles times R times temperature in kelvins divided by the pressure in atmospheres. And so we're going to have, I'm still on the camera, so equals 0.1, moles times 0.0821 times 328 divided by our pressure there, and we'll get our volume. So our pressure would be 1.02 atmospheres. So volume, I get to be 2.64 liters. And I suppose that makes sense because at STP, 1 mole would equal 22.4 liters. And so we're, not super far away from STP, and it's 1/10 of a mole, so 1/10 of a mole would be, so that answer at least is logical. So that's number 29 from your homework.